This coding task wasn't implemented by a human engineer. Instead, it was implemented by an AI agent. So the agent was assigned to this ticket here. It then picked it up. It asked a couple of clarifying questions, which I responded to, and then it just started to work. So when it actually finished coding, it created a GitHub pull request. Let me show it to you. So the agent actually made all of the code changes. It converted from normal CSS to this new framework in all of the files in this project, and even wrote a really good pull request description to describe what was done. This experiment that you just saw used large language models, which are the models behind ChatGPT. Now, often, when people think of integrating these models to their apps, they are thinking about building chatbot interfaces. But in fact, you can actually create AI products or AI-based features within existing products with a user experience that feels much more seamless and potentially more useful. I'm going to show you how the experiment that you just saw works behind the scenes so you can take the insights from it and implement a similar experience in your product. So the core idea is to combine a large language model with a more traditional database like Postgres. This database allows us to add persistent memory to our application. So in our example, we want to remember all the tickets that the agent is currently handling and what's their status. When a ticket has been assigned to the bot in Linear, the bot is responsible to create a new record in the Postgres database in the ticket table, for example. So as you'll see, there's a column here called status, and that one is very important. Before starting to code, we want to make sure the ticket makes sense. So the first status of any ticket that's being assigned to the bot is called validating. And in this step, we essentially allow the LLM the opportunity to ask any clarifying questions about the ticket. And then we wait for a human response to the clarifying questions. So in this step, we actually don't need any LLM. We basically just call the Linear API to see if a human responded to the bot questions. And once there was a response, essentially we can go back to the validating state and so on. So essentially from the validating state, we could go to the waiting for human input state, back and forth until we have the responses to all of the questions. Then when there aren't any other questions, we can transition to the coding state where the LLM goes file by file to make the necessary changes. And then we can basically create a pull request. So that includes using an LLM to generate the Git commit message and the pull request description, and basically to call the API, the GitHub API, and so on to actually create the pull request. Finally, we can transition to the success state, for example, when the pull request was approved. Now, obviously, this is a little bit simplified, and a real coding bot would probably have more states. For example, when someone comments on the pull request or when someone makes changes or things like that. But again, this is just a simplified example, and the main takeaway is that by combining large language models with a user experience that feels more natural, more seamless than chatbots, and a state machine like this, where you basically transition between different states, instead of just having one prompt, you can build really cool AI products.